Hello students, I hope till now you have understood what we have seen with respect to Earth and its interiors. Till now what you saw is actually associated with geomorphology, and now you will be focusing on atmosphere or climatology. Here we will be trying to understand how the air above the Earth's surface reacts and what are the possible circumstances and what are the problems that are actually associated with this. So let us quickly look into atmosphere and understand why it is important from the exam point of view. Some factual information from this chapter is important, but mostly questions will be asked directly from 11th standard NCERT book. But to understand some of the basic concepts, we need to go in detail about this chapter as well. So let's quickly understand what exactly is there in our atmosphere. But before I begin with that, I want to give you some basics with respect to this particular chapter. Now, whenever we consider the formation of the Earth, I have already told you that the heavy particles came at the center and the lighter one moved above. And some gases or gases which are actually present inside, they escaped out. In this, some gases were held by the Earth with its gravitational force, whereas some other gases escaped into the atmosphere. Now, the gases which were kept under the Earth's gravitational force is not uniform. Even here you see different layers. For example, when I take Earth's surface, I usually observe that there are more gas particles at the bottom. And as I move above, the gas particles reduces. Right? So, we usually see that near the Earth's surface, there are certain layers where you find mixture of air. Nitrogen, oxygen, everything is present. This layer is actually called as homosphere, where when you take any quantity of air, you usually see that the composition is constant. 78% of nitrogen is there, oxygen is there, carbon dioxide is there, all this will be present. But above this, you have heterosphere, where the composition varies. One layer will be oxygen, one layer will be nitrogen. Based on the weight of the molecules, you usually observe that layers are present. So this is heterosphere. Here homo and hetero doesn't mean you have multiple gases, so it is heterosphere, and you have only one layer, it is homosphere. No, that definition doesn't say. Here the thing what they are trying to say is, if we take some volume of air, we usually observe that the composition of air is constant in the homosphere, and as you move above, it will be different in the heterosphere. This is one. Second important fact that you need to understand is, if you actually take the Earth's atmosphere, more particles are present closer to the Earth. That is, if I take lower portions of the Earth's surface, we usually observe that you have high density of air. And as you move above, like this, density reduces, or we call low density of air. Why is this difference? This is because of the gravitational force. So why are you talking about this? I'll tell you what is the significance of this. Now, first important concept, that is, just take tire, okay, and pump air into it, right? Now, If there are less particles pumped in this, what will happen? The particles have enough space, they are far from each other. When they are far from each other, will they be hot? I am not adding temperature, I am not heating it, I am just telling you that there is a tire and I am pumping air into it. I have not pumped much. There is enough space. What will happen? Here we usually observe that temperature is less. But when I pump in more air, right, more air, then usually what happens? Spaces will be less available. So between particles, pressure will be more. Because of this, what will happen? As more particles come together, we usually see temperature increases. Here I am not talking about temperature and pressure in physics terms. I am simply telling you a basic concept that if you have a hall, and in that hall if only 10 people are present, you will not see much hot. But in the same hall, if you have 1,000 people present, then usually you observe that the temperature increases. So here similarly, when you look at low density of air, temperature will be less because particles are away from each other. And the second important thing, when we are actually talking about high density of air, as more particles are present, temperature will be usually more. So these two are very, very important for us to actually understand the atmosphere. So here I am telling you that heterosphere, homosphere, then we are talking about temperature. Now here you can observe that the layers which are closer to the earth have more temperature, and the layers above the earth have less temperature. Correct? When I am talking about less temperature, means cold. When I am talking about more temperature, means hot. Now I have already told this example about the convection current, where with the help of water I explained you the concepts. Similarly, when you are talking about a bowl which has water, when you heat it, right, the lower portion will get heated and it will be hot. The upper portions will be cold, correct? Hot rises, cold sinks, correct? Now the same thing happens in the atmosphere also. That is, hot air rises and cold air sinks. Second, I want to tell you that cold air is heavy. Warm air is light. Here I am taking second example. First, what I told you, when more particles are present, that is, if density of air is more, then temperature will be more. You understood this? Don't apply physics here. I am explaining with basic concepts that we talk about adiabatic temperature, adiabatic pressure, where without adding external temperature, we observe certain facts. That is, first just understand that in a room, you had only 10 people who were standing comfortably, no hot, but as I made more people to enter into the room, it became hotter. So with more density, more temperature, correct? Second important thing, you might have actually observed of gas balloons, right? You usually observe in the gas balloon there is fire present. How does the balloon move? The balloon moves because the air inside the balloon is heated. There will be fire, it is heated. Whenever air is heated, usually air moves above, correct? So whenever I heat the air, air moves above. So here, when air moves above, this balloon also moves above. This is what we usually say. Warm air, that is hot air, is light and it moves up. Whereas cold air is heavy and it sinks. These two are very, very important for us. What did we see? Warm air rises, cool air comes down. So this is what air circulation is all about. Correct? So now I have explained you some basic concepts. That is, whenever you move above the earth's surface, from lower layers to upper layers, whenever you are moving, we usually observe that temperature near the earth's surface is more, and as you move above, temperature decreases. Second important thing, what I told you is, warm air or hot air is lighter and it rises above. Cool air is heavier and it sinks down. So these definitions are very, very important for us to understand. Then, the most important point is, when you have cold below and warm above, another example, warm below and cold above, right? Here usually you observe that in this case, right, cold which is heavy is below, warm which is lighter is above. So mixing is less. But here warm is light, cold is heavy. So usually what happens? Cold will come down, heavy will move up. So here mixing is more. So what did we understand? We just understood that with increasing height, if temperature decreases, that is, hot is below, cold is above, then mixing or circulation is more. This is the phenomena that we usually observe in the lower atmosphere or troposphere. But as we move above, you have other layers where we call it as stratosphere. And here what happens? With increasing height, temperature increases. That is, cold will be below and warm will be above. So this atmosphere, mixing is less. Here mixing is more. So we call it unstable. And here we call it stable. All these words are very, very important for us to understand this particular chapter. So let's quickly get into the chapter and see what are these concepts. The first major thing that you need to observe in this chapter is, without this blanket of protection, we would be baked alive by the heat of the sun during the day and get frozen during night. What is the meaning of this particular statement? It says that sun's insolation heats the earth's atmosphere or earth. When we actually consider the earth, sun is the main source of insolation. And it is believed that sun's rays are very small. So even though if you have carbon dioxide, clouds and all, not everything is absorbed. So most of it will come and fall on the earth. Now earth gets heated up. You know that every heat object or hot object emits certain radiations out to become cooler, right? Just take the example, you have a hot tumbler, and if you go closer to it, it will be hotter, but you can feel that it is emitting after a particular point of time. If you stop heating it, why does the tumbler cool on its own? You have a cup of tea, why does it cool on its own? Because it emits certain radiations. Similarly, every hot object has the property to emit radiations and become cool. Earth also emits radiations and it wants to cool. Morning also it emits, evening also it emits. Morning, it absorbs more, emits less. In the evening, when sun sets, it absorbs less, emits more. So in the night, it cools quickly because it is emitting continuously. Whereas in the morning, it takes time because it is absorbing sun's rays continuously. So Earth also will emit back its radiation. Now, what will happen? As the radiation of the Earth comes out, we usually see that the wavelength of that particles are usually more. Because of this, carbon dioxide and others usually absorb these heat waves. So, Earth radiation is absorbed. Let me take here. Earth radiation is absorbed by carbon dioxide. Carbon dioxide becomes hotter. Now, every hot object has a tendency to emit. So, it emits back something here. So, again this comes and falls on the Earth. Again radiation happens. Let me take, there are more carbon dioxide present. Again the process continues. Can you see? Heat whichever came from the sun is not being allowed to escape completely, but we are usually observing that it is absorbed by the carbon dioxide and it is actually holding the heat here itself. This is actually called as greenhouse effect. If you actually move to countries like Norway, Sweden, Scandinavian countries, usually closer to the poles, we observe that sun's rays are very small in this region. Due to this, what happens? They usually create a chamber, glass chamber, plants and all will be there, right? Now, the plants require more temperature to sustain. Now, here what they do, sun's rays usually penetrates inside the glass chamber and it gets heated up. Now, when the sun's rays wants to go out, the glass does not allow the sun's rays to go out. Whatever sun's rays comes in will be trapped inside and it does not allow it to escape. Because of this, temperature in this region usually increases. So even though sun rays are limited, as it is trapped, we usually observe that it will usually have hot or more temperature for longer period of time. You can take example of a car which is actually placed in hot sun. Once you go inside, you can see you will be burning. But once if you open the windows or if you open the door and come out, the same temperature will not be there. The reason for this is car also absorbs sun's rays and it does not allow this to escape. Now, carbon dioxide and other greenhouse gases, what we call, usually have a tendency to absorb escaping Earth's rays and it emits back. Due to this, it acts as a greenhouse chamber. Atmosphere usually acts as greenhouse chamber. Carbon dioxide was one of the most important component of this greenhouse chamber. Now the biggest problem is with increasing greenhouse gases, that is carbon dioxide, methane, all this, more particles are present and it is actually keeping more heat in the surface. More heat is trapped. As more heat is trapped, what is the problem? Temperature is increasing. Now, when we talk about cities, pollution is more carbon dioxide is there. Buildings are very closely present. The concrete, cement and other things that you use in the buildings also absorb more heat. And The air particles, warm air, is usually present inside the buildings, or between buildings the air is present and it cannot escape. Whereas when you go to villages, there these concrete things are not present, due to which we usually observe that the heat escapes. So, if you have a city and a village nearby, the temperature during night in the city will be more. In the village, it will be less. Even though the difference between this is just 10 to 20 kilometers, the reason for this is the concrete roads and all trap more sun's rays and does not allow it to escape. Whereas in villages, it allows to escape. Because of this, the urban areas experience more temperature. We call it urban heat island. Why? In the urban area, the heat is trapped. And it is only an island because the surrounding areas are cool. Only the urban area is warmer. Right? So let's quickly see some important definitions here. Carbon dioxide released in the atmosphere creates a greenhouse effect by trapping heat radiated from the earth. It is called as greenhouse gas. I have already explained this, and it was very, very important initially because earth would have frozen in the night if carbon dioxide was not present. But now with more carbon dioxide being present, it has become a global warming issue. Now, when we talk about composition of the earth or atmosphere, we are actually talking about certain gases that are present. First, let us look at nitrogen, which is actually almost around 78%. The air we inhale has nitrogen present in it. But fortunately, our body cannot absorb this. Only we use oxygen and exhale nitrogen out. Even plants require nitrogen. They inhale it, but they too do not have the capacity to use it. So they are actually dependent on bacteria which can convert the atmospheric nitrogen into the nitrogen which is absorbed by the plants. That's why nitrobacteria, some bacteria are very, very important. You go for leguminous plants in between the crops just to ensure that these crops trap the nitrogen and make it available in soil in such a way that other plants can absorb it. Right? Nitrogen is the important factor. Second important, you are all aware about oxygen, which is available plenty. Both plants and animals require it. And plants require carbon dioxide for photosynthesis and they emit oxygen out. So plants actually try to maintain a balance of oxygen. Unfortunately, whenever we cut more trees, then the oxygen releasing capacity is reduced and the imbalance is usually seen in the atmosphere. Now, in do you know, again they are talking about when air is heated, it expands, becomes lighter and goes up. This I have given you. You have to write down this particular point. Cold air is denser and heavy. So that is the reason it sinks. When hot air rises, let me take air was present here. This raised up. Now there is vacuum here, cold air comes in. So here, when hot air rises, cold air from the surrounding area rushes to fill in the gap. That is how air circulation takes place. This is what we have to look. Then we are talking about carbon dioxide, which is very important for photosynthesis and it releases oxygen. Humans do not absorb carbon dioxide, but we emit it through respiration. But the most important sources today is transportation and other pollutions which are emitting more carbon dioxide into the atmosphere. Now, once it increases, it affects the weather and climate. Then we need to talk about different layers present in the earth. Let me go from below. In this picture, they are actually talking about height here, 10, 20, 30, 40, 50, and Can you see there is a line which is drawn in this fashion? It increases in the stratosphere. Again, it moves in the mesosphere. The meaning of this is, here the x-axis, they are actually talking about the temperature. Y-axis is height. I told you, in the troposphere, that is the lowermost portion, temperature is high at the surface, and as you move above, temperature decreases. Can you see? With increasing height, temperature is decreasing. The height of this is almost 13 kilometers. Major atmospheric phenomena is usually absorbed in this region. Next, can you see with increasing height, temperature increases? Correct? Here, I am talking about stratosphere. This region has ozone content present. And ozone is very important for us because it absorbs UV rays which are harmful to us. As it absorbs UV rays doesn't reach the earth, and plants, animals, all these are existing. So ozone layer is very important. Where it is present? It is present in stratosphere. And stratosphere is usually free of clouds. Due to this, it is good for aircrafts to move. 3 factors: with increasing high temperature increases in stratosphere. Second important factor, ozone is present. Third, clouds are absent, so aircrafts usually move in this region. Then when we actually look at the other layer, that is mesosphere, can you see? Again, temperature is decreasing with increasing height in the mesosphere. And here, usually the meteoroids, that is stones and other particles from the atmosphere or exosphere, outer space, whenever they enter into the earth, they get burned in this region. Meteoroids burn in this region. Then you have thermosphere and exosphere. Thermosphere is the last layer. Here ions are present. Usually you might have observed the FM and all you get, right? So these are usually associated with the ion particles which are present in this region. The uses of these regions will be explained to you in detail when we go to higher classes. But here what you have to observe is, between troposphere and stratosphere you have a layer called as tropopause. The meaning of this is, see, in troposphere with increasing high temperature decreases, but in stratosphere with increasing high temperature increases. Tropopause is a layer in between these two, and it is present in such a way that in that layer we usually observe temperature difference. That is, there will be mixing of both troposphere and also stratosphere, and in this region the mixing will be almost there but not complete. But once air passes this, then it enters into stratosphere, where you will see with increasing height temperature increases. Below the tropopause we usually see, as you move down, temperature increases. Correct? So these are very, very important for us. Exosphere, the uppermost layer of the atmosphere. This layer has very thin air. Light gases like helium and hydrogen float into the space from here, right? Then it is very important for us to look at some of the basic definitions of weather and climate. You should be knowing that weather is the hour-to-hour or day-to-day condition of the atmosphere. But when we talk about the average weather conditions of a place for a longer period of time, it represents climate. Weather is a short phenomena on a particular place, climate, longer period. Average of this is climate. So these two are very, very important for us. Then, what is temperature? The degree of hotness or coolness of the air is called as temperature. And what depends? An important factor that influences the distribution of temperature is insolation. That is, wherever the sun's rays fall more, will the temperature be more or less? It will be obviously more. Wherever sun's rays are less, will the temperature be more or less? It will be obviously less. So temperature depends upon insolation of the sun's rays. We usually observe that sun's rays are more present near the equator, because of which temperature is more. As you move above, we usually see that the sun's rays are slant and they are very less. And because of this, we usually observe the temperature is less in the poles. That is, equator is at 0 degree, poles is at 90 degree. As we move with the latitude, temperature keeps on decreasing. Temperature will be more near equator and it will be less near poles. This is what they want to talk. The amount of insolation decreases from equator towards the poles, and this is the reason temperature decreases in the same manner, right? So these are very, very important, and whenever they give you question about urban heat islands, temperature in cities is much higher than that of villages. The concrete and metals in buildings and asphalt of roads get heated up during the day. This heat is released during the night. Also, the crowded high-rise buildings of the cities trap the warm air and thus raise the temperature of the cities. So this is the reason, geographic reason that you have to write for urban heat islands is this paragraph, right? Then we need to talk about air pressure, which I have already told you. You will be surprised to know that air above us presses us with a great force on our bodies. However, we don't feel it. The reason for this is, see, I told you that due to gravitational pull, you have more air masses present above us. So they are exerting high pressure on our body. But still, why aren't we facing any pressure? The reason for this is, within our body, you have opposite air pressure exerting. So these two balances. As you move above, whenever you climb highest peaks, the problem there is air pressure from above decreases. I told you air is present more at the bottom. As you move above, it is present less. So as you move on the top of the mountains, we usually observe that their air pressure is less. When air pressure is less, what will happen? Our body pressure doesn't change. It will be more, but the pressure that is coming from above is less. So usually from high pressure to low pressure, things move. So blood usually come out. So usually we observe that there will be bleeding in the nose and all. The reason for this is difference in the air pressure. So similarly, in moon, when you go, there is no atmosphere present. There is no air pressure. But our body is made suitable for the Earth's surface. So when we go there, astronauts have to use a different air pressure just to ensure that they don't bleed. This is what they have given in Do You Know? Air pressure is defined as the pressure exerted by weight of the air on the Earth's surface. As we go up the layers of the atmosphere, the pressure falls rapidly. The air pressure is highest at the sea level and decreases with height. I have told you all this. Horizontally, the distribution of air pressure is influenced by the temperature of air at a given place. In areas where temperature is high, the air gets heated and rises. Correct? For example, if you have atmosphere, sun's rays is there, it's heating this particular air, it became warm, it rises. Now, when the air rises above, will there be more pressure on a person who is standing here, or if the air is coming below and if there is a person standing, will he experience more pressure? Obviously, here you find low pressure, here you have high pressure. This is what they are talking here, creates a low pressure area. Low pressure is associated with cloudy skies and wet weather. Why? The reason for this is, here we are talking about air is rising above, correct? Now, you have hot air. Let me add moisture to it. And this air is rising above. Now, hot air, when it rises, it expands. Earlier it was very small, now it expanded because space is less. and it becomes cool. Correct? Now the moisture which is there, here it becomes water. If you further move above, it becomes cold and it becomes ice. Right? So whenever air moves like this, as temperature decreases, you usually find moisture becoming water and water becoming ice. But whenever air moves like this, ice becomes water, water becomes water vapor. So which is more desirable? This is more desirable. Can you see here? Low pressure is associated with cloudy skies and wet weather. This is the meaning. In areas having lower temperature, the air is cold. It is therefore heavy. Heavy air sinks and creates a high pressure area. I have already told this. High pressure is associated with clear and sunny skies. Very, very important for us. Right? I told you, whenever the air moves below, you won't have clouds. But whenever air moves above, you will have clouds. The air always moves from high pressure areas to low pressure area. This is a basic concept, that air moves from high pressure to low pressure. Then air, whenever it moves from high pressure to low pressure horizontally, it is actually called as wind. Right? Air, whenever it is moving from high pressure to low pressure, it is called as wind. You can see wind at work as it blows leaves and all, no need to think much. Usually this fact is important. A wind is named after the direction from which it blows. That is, if a wind is blowing from west, it is called as westerlies. Not to the direction it flows, but from the direction where it originated. Okay? Winds are actually differentiated into three types. Permanent winds, that is, these are present on the earth's surface throughout. Examples of this are trade winds, westerlies and easterlies. I have not explained this. It takes at least 1 hour for me to explain the entire process, but just understand. Permanent winds are permanently present on the earth's surface. In higher classes, we will be going in detail. Seasonal winds, it keeps changing. For example, monsoons of India, right? Remember this. Local winds, if you go to the coastal areas, right? We usually observe that during day, sun's rays fall more on the land, or land absorbs more heat. Water, even though it absorbs more, water as it is spread, it will have less impact. Let me explain this particular concept in detail. I have land and I have water. Sun's rays are falling on both. Now, land do not allow sun's rays to penetrate deeper. So, same amount of heat is present in this particular portion. But when I am talking about water, now this portion of water gets heated, but water allows it to move. So due to this, we also observe that more area or more volume is heated. Less volume is heated, more volume is heated. Now, here you usually see high temperature, here you usually see low temperature. Correct? Now, whenever you have high temperature, air is heated. Correct? Whenever air is heated, it moves up. So, if I am talking about land and ocean, here I have land and here I have ocean. Air is moving above, low pressure, and here it is cold comparably. So, I have high pressure here, it is coming down. From high pressure, it moves in this way, low pressure moves up, again it moves in this direction. This cycle is seen. So, usually we observe that during day, we get winds blowing from ocean to land. In the night, what happens? In night, usually the sun's rays falling is less. Earth will cool quickly. So usually we find land is cool. Water takes more time to emit. Because of this, this is warm. So warm, low pressure, cool, high pressure, correct? High to low, from land to water. This is called as local winds, right? I'll explain this much in detail with pictures when we go to further chapters. Then the most important concept is about moisture or rainfall. You all know that sun's rays, when it falls on the water, it evaporates and becomes moisture. And as it moves above, it condenses and gives rainfall, correct? This particular way of sun's heat leading to rainfall, because the air is rising above and giving rainfall, is called as convectional rainfall. There is another process, that is, just remember that if there is any process on the earth which makes air to move above, all these will actually lead to rainfall. Why? The reason for this is, air when it rises above, it cools and it gives rainfall. One is because of the temperature. It heats, so warm air rises, cools, and it gives rainfall. Second, let me take you have mountain. Air came and hit this. So air started moving above. So when air started rising above, it cools and it gives rainfall. This is called as orographic rainfall. Now once it crosses, what will happen? It will come down. Whenever air comes down, what will happen? We usually see that there is no rainfall. Winds are blowing towards the mountain. This is called as windward side, and this gives heavy rainfall. And when it is coming down, we call it leeward side. And here, less rainfall, or we usually say no rainfall. This is called as orographic. And when you go to 60-degree latitude or so, here we usually see that cold air from poles, because poles are cooler, and warm air from equator, because equator is hotter. They both meet. Whenever they meet, it is believed that the warm air rises above. And whenever the warm air rises, anything which makes it to rise, it gives rainfall. So this is actually called as cyclonic rainfall. You can see cold air, warm air. Here we are talking about relief or orographic rainfall. This portion is actually called as windward side, and this portion is called as leeward side, right? So these are very, very important for us to understand. So only one factor that I want to tell you here is, jet planes flying in the sky leave a white trail behind them. The reason for this is, the moisture from their engines condenses. The moisture which is released by the jet, it condenses and it looks like white tail. Guys, in this chapter, whatever is there and the basics with respect to this I have explained. Now, there are other topics associated with this. I know you will be having a lot of doubts, which we will be covering over a period of time. So have some patience and let's quickly move to the next chapter.